All right, so welcome to my session, Feeding the Modern Data Warehouse. I'm glad to be part of that Data Platform Virtual Summit in 2021. This is going a great summit. I saw all the presentation, the presenters, they are very good. So, who am I? I'm a data engineer, solution architect at Avanade. I'm specialized in both ETL development using various ETL tools like DTS, SSIS in the past, Hummingbird, Genio, Informatica, Data Stage, various data warehousing experience here, pharmaceutical, finance, insurance, manufacturing, education. I'm specialized in data warehousing, BI, big data. So I wrote also several books on data integration, on SSIS, on data factory, Azure Data Factory. And I'm also data platform most valuable professional for the past 13 years now, and I'm leading in Montreal data platform user group. So what's the agenda today? Today we're going to talk, of course, about the modern data warehouse, what it is, and how did we get there. The modern data warehouse ETL or ELT pipeline architectures, the technical challenge that comes with it, how to query the modern data warehouse, and cloud advantages over on-prem data warehouse. All right, so on-premise and cloud. So basically, on-premises data warehouse, this is what we did for what I did since the beginning of the century, right? So we have several sources here. We have our sources here, so it can be REST, it can be APIs, but mostly at the beginning of the century, it was something like Oracle data warehouse here, or Oracle data sources, CSV file, text file, basically. And then after that, we have our staging area. PSA means persistent staging area, so we keep all the history into the staging. We have our data vault here, which is the data warehouse. This is the most modern inception of the data warehouse on-prem. And then after that, we have the business rule that we need to address, and we build data marts on top of it. So data mart might be a database, and we report directly from that database, or we use a cube at some point. So we're able to report from the cube or from Excel directly to the queue. This is what we had when we were on-prem, basically. So what's the issue with that? The principal issue that we have is uh, it has some caveats, right? As I wrote here. So opening the servers, nowadays we address the data might come from the cloud more and more. So opening on-premises ETL server is to the internet is a huge security breach. Also, the one of the ETL tool that we use on-prem, if you are in the Microsoft world, is SSIS, so SQL Server Integration Services. So it's good for structured data, but for semi-structured or unstructured, it's not the best tool. Also, in the on-prem, this is what we have. In the cloud, it has to be different, and this is what I'm going to explain on the next few slides in this presentation. So first of all, let's talk about the different type of services in the cloud. This is the principles one. So we have infrastructure as a service here, IaaS. We have platform as a service, PaaS, and software as a service, SaaS. Just to explain you how it works, basically on premises, we're responsible of everything. We're responsible of our network, the storage, the servers, VMs, if we have any. Then we choose the OS that goes on that VM, the middleware, the runtime, our data, and the application that will use to show or access this data. Infrastructure as a service, basically, it's a VM in Azure. It's basically a VM in the cloud. So here, the networking, storage, server, virtualization, right? It's a VM. So everything is done for us. The only thing we have to do is what OS are we going to use in it, what middleware, what data, what application are we going to run on that VM here. Platform as a service, I would say it's basically you have from the networking to the runtime here, everything is managed by the vendor. A good example of that would be Synapse. Because Synapse will access everything from the web, so everything from the browser. So Synapse is a good platform as a service example here. Then you have your data. That of course the data cannot be part of the platform as a service offering. Although if you're using Azure SQL, it's platform as a service database here. Azure SQL, not the managed instance, but the Azure SQL DTU base, basically. And then you have your application that will access this data. So software as a service basically is like Gmail or Hotmail or Outlook.com. I would say that everything, the application is hosted by the provider, the data. You don't have, you can interface with the data, but you cannot store the data directly. You don't know where the data is basically here. And all the rest is managed by the vendor. So if we compare that to a pizza, right? So when we order pizza, at some point, we have, if we make it at home, right, we do the pizza by ourselves. So we're responsible to get the cheese, the toppings, the tomato sauce, the pizza dough. Then after that, we're responsible of the heating here, the sodas, and the dining table. So we do everything on our own. IaaS would be pizza as a service. So basically, so would be you go to the grocery, you purchase a pizza, and you bake it at home. So you don't have to do anything. You simply remove the plastic wrapping, and you put it in the oven, and after a few minutes, it's ready for you. If you don't want to do it, some platform as a service here would be that you order your pizza and it's delivered to your place. So you don't need to reheat the pizza. You don't need to do anything. You just have to take care of the sodas and the dining table. And if you go to the restaurant to have your pizza, so now it's software as a service. So you just order the pizza, it comes to you. So what is the modern data warehouse and why did we get there, basically? Why do we need a modern data warehouse? So the on-premise data warehouse challenges are the one that I'm going to talk to you about here. So basically, when I started that business at the beginning of the century, we're receiving a CD-ROM, 700 megs, which is which was quite large at the time. So sometimes we have a few CD-ROMs they were containing text files, compressed text files, and we had to upload those files onto the server. And then we had a few days, like 4 to 5 days, one business week, to load that data into Oracle, into our Oracle data warehouse or SQL Server data warehouse at the time. So the problem is now we have more and more volumes. I'm talking about a monthly sets of CD-ROM that we're receiving slowly. We started to have weekly loads, like I would say mid 2000s. We start to have to receive those CD-ROMs weekly. So we were receiving the same number of CD-ROMs, but with more data, more details to that data. And after that, shortly at would say at the beginning of the 2010s, it's become daily. Now, people want real-time or near real-time data more and more. So this presents a challenge for an on-prem data warehouse. The on-prem data warehouse was able to deal with up to the daily the daily schedule. If I'm doing real-time load, it's more complicated. It can deal with micro batches of every 15 minutes, but still, it's the more data we'll have, the more challenges it will be for our on-prem data warehouse. Also, new type of data sources, right? How many times I've been asked to load a PDF? my data warehouse at some point to read a PDF or to read an image. As I said, SSIS or other on-prem ETL services were not meant for that. They were meant to load mainly structured data here. Now, if I use Python, I can read video, I can read an image, take the points on that image that I'm interested in, and do something with it, do some kind of analysis with it. But still, images can be huge, videos can be huge, so it's tough for an on-prem installation or on-prem data warehouse to deal with it. And the cloud-borne data. Cloud-borne data means that, let's say, all the Web 2.0 and more data that we have, like Facebook comments, I would say, Twitter, and all of these these data that are in the cloud. And when you think about that, Twitter, we can have a lot of messages that we want to parse. So for an on-prem data, first thing first, accessing those cloud-based, cloud-borne data is challenging. Second, it's not meant for that. So then after that, when people evolve from the data warehouse, they say, okay, now we have an issue with those data semi-structures and unstructured data. I talked about videos before, I talked about pictures before. So they had issues with that. So they say, okay, let's build a data lake. Let's forget about the data warehouse. We'll build the data lake. Sometime they say a data lake will be a database that we don't have any data model, right? It will be a bunch of tables, and we load the data into this table. For images, we could use, and videos, we could use var binary max in SQL Server. And for JSON now, JSON is now supported. XML started to be supported in the mid 2000s. So, but the thing is, with the data lakes, they are easy to load by many different people at different time. There is no, you don't need to have special programs to load it, because basically you upload data. Most of the time, now I'm talking about databases, but we add file servers that act as data lakes. So people were simply copying the data onto the file server, and it was taken by loading program, or they were querying that data by themselves here. The problem is, if anyone can load data, but probably the consistency of the structure will vary, right? And the data quality will vary too. And schema and read, which is something that we wanted schema and read because we didn't want to do any data model. We wanted to say, you know what, I will evaluate the model when I read the data. It's harder to query compared to a relational and the schema and write model here. So it's much easier to read a relational model because most of the tools are made for that, first thing first. And second, the data, there will be a data model. So people thought about what we're going to do with that data. Then, so as compared to that, we had the data warehouse I was talking before. I'm sorry. This is the easiest way to query because the data is clean and validated. So it's all the opposite of we have with the data lake. We create a great deal of effort to load data though. So we need to do a data model. And it's schema and write, as I said before, and we cannot as much volume as we would have onto a file system because you need to choose what type of data you're going to keep. How long you're going to keep that data, because you might not have enough power, enough compute on your database server. So the other approach to load the data warehouse first. So here we talking about on-prem basically. So we're extracting data using ETL tool. We're transforming it and loading it as soon as possible into our enterprise data warehouse. And then after that, we were using BI tools on top of it to create a data mart at some point, or to create a model into the BI tools, or it will be able to be consumed by other data lakes here. Now, the newest way, I would say, the way that we do use read down in the cloud, we're going to ingest the data first. So take the data from its source, bring it to a storage. Now in that storage, we're going to say, okay, we have some streaming data, we have structured, semi-structured data here, HDFS, Databricks, DBFS, anything. So here, then we're going to transform the data here. So it's scale out. So we're going to transform the data from its source here and load it somewhere else after. That somewhere else might be other place into the data lake, or we're going to feed our data mart directly from the clean data here. We're going to talk about the zones of the data lake further. And the data lake, basically, it's a combination of data lake and enterprise data warehouse. This is how we should see it, because a data lake by itself can live, right? But it's limited. We have all of these challenges that I talked before a few slides ago. So now with if you say, okay, my data lake is a combination of data lake and data warehouse, um, it's a much more flexible architecture. And this brings the data lakehouse, right? So data lakehouse, basically, you have the data warehouse, you have the data lakes. So we have the data warehouse since the late 1980s. Then they say it's not enough flexible. Let's have a non-structured data. So let's build a data lake. Now in 2020, let's have a data lakehouse. So data lakehouse is a concept created by Databricks. You build a data lake first, okay? And then after that, as need arise, you build cleaner table for specific purposes at some point. And then after that, once you know what you want to do, the clean table can be later integrated into a data warehouse or a data mart. So this is how it works. So if I go back to my slide here, this is basically what we see here. I can do BI with it, right? So as soon as I know what I want to do with my data, the data is clean enough, I can do some BI here. I can here do streaming analytics to see real-time data science, and machine learning based on the data lake. So this is how it works. So the data lakehouse, this is, I would say, the way we use data in the cloud. Most of the time, we always need, before that, in the data warehouse, we had the staging area, we had the enterprise data warehouse, data mart. Now we have different zones in our lake, and then we have our data warehouse or our data mart. All right, so, and this brings the Microsoft modern data warehouse architecture, the way Microsoft is seeing this, basically. And basically, you have your ingest and prep. So you can use Azure Data Factory, Azure Databricks to bring the data into a data lake storage. And then after that, you can say, now that is in my storage, so that my data lake, let's bring it into a model. And the model will be our data warehouse. And we can use Power BI or Excel or other tools to visualize the content of what I brought here. So basically, this is how it works. Let's move on. So what are the technical challenges to it? Because having this image is easy, but if I start from scratch or if I start from something in the cloud, what would be my most technical challenges here? So first thing first, the data lake is not a data dump. You don't want to, it's not a cesspool. You don't want to bring everything into at the same place. You need to segregate your data. So you can have your raw data, and then you have your curated data. So this is, and then after that, you can use this data to query. And in between, you can have several layers that you will see between the raw data and the curated. I might have another layer here where I do some basic cleansing here. Also, streaming, right? Now every time I build a new architecture, we're talking about, okay, let's prepare for streaming data. Streaming data is challenging because the stream ingestion here, on-prem, it's almost impossible. But in the cloud now, because we can have a lot of volume here, You need to have specialized tools like Stream Analytics, or with Databricks, you have the auto loader. You need to have a cluster running 24/7 if you're streaming 24/7. And you need to think that, okay, let's say that something break. I need to go back in the past. I need to reread those messages. So you need to prepare for all of this here. And those tools here can be costly. So micro batches sometimes might be less expensive, and you can always, from micro batches, evolve to streaming in the future. Also, the different file formats, right? So we want a file format that is scalable at some point, so that we can compress here and we can split at some point. When I say that, I mean a CSV file. This is what we were using a lot on premises. Now we have different formats. We have Avro, we have ORC, but Parquet is de facto a standard now. So what's happening is that now you can see that Parquet is going to do like you have the row one, you have your session ID, you have your timestamp, and you have your source IP here. Parquet is going to compress this data. So organize this data that is, first of all, splittable. So if my file is splitted on many partitions, I can always reconstruct the files using it, because my file is segregated into several zones here. Whereas if I have CSV, I cannot split that cell here. So this is I can split the row. With Parquet, I can do it, and also Parquet will compress the data by column, which means that it's easier to compress of kind of a big int here, or integer data that takes less space and timestamp. If I have two timestamps that are the same at some point, they will be seen as is if I was only one. So it's easier to use Parquet in the cloud. And also Parquet will contain the schema. So when you read the Parquet file, you have the schema. It's not only string that you will have with the CSV. Right? And also the joins. We need to be careful with the joins, because joins are costly in the cloud, because your data might be on multiple partitions that might be on multiple different machines. So that's why you need to think about what kind of joins I'm going to do, right? And that's why the things like architectures that requires multiple joins does not perform well on the cloud here. So Parquet compression is a no-brainer, because Parquet is very it's a compressed format, and it's splittable. So we can partition a Parquet file much easier than a CSV file. And if you have large volume of data to be partitioned, to join them, you need to co-locate them onto the same partition or in the same machine to optimize the response time. Because otherwise, if you want to join data from table A to table B, what will happen is that we're going to need to bring the data to the same disk, the same machine at some point, to make a join to the same compute machine. So because now the data is distributed on many machines in the cloud with Spark here. So data is generally distributed on many files, and the indexing does not exist there much. So we can do a Z order. We need to talk about that later, in data skipping, to achieve better performance here. So we partition the data, and then after that you can reorganize it here. So different type of join. Shuffle have join here. This is the most basic way to join tables in Spark. So basically, this is the type of join that I was talking about. I'm going to show you in the example layer. You have the broadcast as join here. These are the most two commons that we find here. So the broadcast as joins, basically, if I use my laser pointer here, the broadcast as join, it's like if you have dimensions and you have fact tables, you're going to replicate your dimensions on every nodes that you have. So on every node of your cluster here. So every time you want to join your fact table to a dimension, the data will be co-located. It will be at the same place, and the performance will be very good. cartridge joints. I don't need to explain that much, right? And these are also some tricky joints here that we don't use a lot, like the one-to-many joint, single row can match many rows on the other table. Usually, we try to use broadcast as joints here, and theta join here to label strictly by key. But this is rarely used. Mostly, maybe for your users, you might need those kind of joints, but usually the most that we use are, I would say, cartridge joins if you want to do a cartridge project of the data, but basically the first two are the one that we use the most. So shuffle left join, this is how it works. Basically, you have your partition one here on stage. So you have many stages here. So your stages in Spark is a step, I would say. So step one, I'm going to read my data from the partition one. Step two, I'm going to read my data from partition one here. And stage one, yeah, in that case, I have a small source. I can read the data from both partitions. So what will happen in stage three? I'm going to bring the data from partition one, all of the two together here, 10, 10, and 30 here. I will match it to the 30 that is here. And then after that, I will bring the data here in. So we'll do the join. Basically, as you can see, I need to read the data on different. I need to bring the data together here, and then after that, the stage three, I'm going to join that data here. So this is the partition two here. I have all the 40, the 20, the 50 from the partition one here. So I joined this data together. This is a shuffle half join. It has to read the data and match it. I would say set by set or row by row here. So broadcast has join. As I said, optimization here. When the one of the data frames is small enough to fit in memory of a single machine. Basically, I have a small data frame on every machine here, and the large data frame is able to access it. So parallelism of large data frame is maintained, right? So everything is in parallel because I don't need to read the data much. It's already on that machine. And also, how are we going to model? I told you that joins were quite challenging on Spark. Now let's talk about I would say the most two common ways I see data is on the cloud when we do the modern data warehouse. So we have the basic star schema here, right? The star schema, this is the one we know and love for the past 30 years. This is the most easiest way to consume the data because you would always want join away from your table. The other way that people had with Hadoop, we add that a lot. Hadoop, which is before Spark, it's still used though. But I mean, with the math per reduce, this is what we had. We try to build a flat table. So instead of having those joints here, we resolve those joints to build a flat table. The challenge with flat table is that Excel has a maximum of 16,000 columns here. So, but and anyway, when you can imagine that if I scroll in Excel to find all my thousands of columns, it's going to be challenging. So you need to be careful with flat table. Sometimes we do it to accommodate some reports, or we do it because we have a complex star schemas or a combination of star schemas that we want to bring together. But basically, most of the time we're going to use star schema. Oh yeah, and also star schema here. If you use Power BI, is the most I would say scalable way of building your report because Power BI is going to deal with those kind of architecture of data model much more easily and with much more performance wise than a flat table. So the architecture, the pipeline of the architectures too, right? So here we have the Lambda architecture. This is something that appeared with beginning of the 2010s. So we have our streaming data here, then we have the streaming layer. We have our batch layer here. So we bring the data, we have our batch data here. We have a serving layer here that would basically read the data from our data lake. We do some queries on top of it and then we can we can go into our system, the consumption. Here it might be a star schema based on the delay. Streaming data was meant to be or was seen to be consumed directly. So you consume the data using special report. It will read from the streaming layer. Now, the problem with that architecture is that sometime in my batch layer, I wanted to access streaming data, the data that was just streamed. Because I have, let's say you have a fact table, yeah, you need to have a dimension. The dimension is not yet in my systems here, right? Dimension is not here, so I want to access it directly. And I know it's from my streaming, I want to access it here. Then at some point, to complete the data in the streaming layer, sometimes I had to do the opposite. I had to basically bring data here to my streaming layers. And we had a lot of those kind uh, of bypass, I would say, here that we needed to do. And streaming error was the same too, right? So it was very complex to manage. So this is what we were using at the time. So that model, lambda architecture, has been replaced by something else, and I'm going to get there soon. So Databricks Delta. Databricks said, okay, let's optimize. Let's build an engine that will help people consume the data in the cloud. So what they did, basically, they created an open storage format, a number format storage layer. I'm sorry, here that support ACID transactions. Usually we don't have it in the cloud, but it supports ACID transaction. Basically, Databricks, what it does, it adds a log file on top of your Parquet files. And it's very scalable. Streaming batch unification, which is very important here. So I'm going to talk about that later. We call it the Delta architecture. So, and then schema enforcement. So, and it can, if your schema is drifting, it can accommodate schema variation here. And time travel, you can go back in the past to see your previous transaction. So basically, it's a log file that they added on top of it. So this is the data architecture I was talking about. So, and these are the various layers that we have here. So basically, we have our data sources here, and we query them using that. You bring them into raw tables, raw zone on your lake here. Sometimes you will see bronze tables here, and then after that you have your query table. So the query result, but the different here is that you will join data here to create your dimensions, and then the goal, you're going to create your fact tables. So you're going to clean your data here, and here you're going to join the clean data together to be able to query and use it with your consumption systems, consumption layer here. And then on top of that, you have also the common data model, which is also known as Dataverse. So what is the common data model? So basically, how many times did you have to do a model based on an account or based on sales, right? So what Microsoft and Adobe and SAP wants to do here, they want to say, let's align it to an existing data model as a basic. And they use Microsoft Dynamics at first for that. But the modern data warehouse lifecycle with the common data model, this is how it works. Basically, you ingest data using Power BI. Using Power BI data flows here to ingest the data. So you're going to put them into special common data model folder. I'm going to show that to you after. And then after that, you can read that data with the same data flow. So basically, the analyst with the client will go there. Okay, let's see what you want to do with your data. So they would ingest the data in the common data model. And after that, they will send that to the IT department or other department to industrialize that common data for common data for data. Now, this slide is a bit dated because now Data Factory or Synapse can read and write into the common data model. Databricks can do it. Machine learning and SQL data warehouse, they can both read from that layer here. So the common use case, I'm going to show you that in my demo after for it, is basically to read some of the data, you don't want to have the full volume of data in Power BI because you want to basically build a model at some point. You don't want to spend months to build the complex data model. You want to build a model based on what you're going to need from the data lake. And then after that, you ingest that data into those folders, and you'll be able to industrialize it with ETL or ELT tools. Yeah. So this is how it works. Basically, you have your data integration. You can integrate your data from many points here, and it can be used with Power BI here, AI for sales. It can be used by other applications afterwards. So this is a node structure, but basically the way it worked is you have your Dynamics 365. It was based on that. And then after that, it's like you have your Power BI, you have many workspace on your Power BI, and you have your folders. And the details of it is, in my folders, I have modeled the JSON. This is what we had before. Now they have changed it a bit, but still the idea is the same. And I had that model and knew where the data was on my in my data lake here. So we knew what type of data we had and how to use it. Because with the data flow, I would define some basic transformations. So now let's do the demo. Wait, I will stop presenting for now. Okay, I'll simply stop presenting for now. That's fine. So you see my image. Let me share my screen here. Yeah, this is the one. Okay, let's go to the browser. So to use this common data model, you need to have a premium workspace in Power BI. So if I go here, I go to my workspaces, you will see I have a premium here. So go to my premium here. I will take Microsoft 1 year of stock value here. So I imported that data into my data lake before, and then I did some transformations on top of it, basic transformation I'm going to show you as soon as it arrives. So I have my source here. Let's go to the source. Wait, it will arrive. So this is my, yeah. You see, it comes from I'm sorry, it comes from a web URL. Then I promoted the headers here, and I was able to save it at the end of the day. I was able to do some transformation and save it into my common data model folder. So once it's there, after that, I can do some reports on top of it, or I can use, I'm using Synapse here. And from Synapse, let me go to the data here. Let's go to the pipelines here. We go to my factory. From Synapse, I can read the data directly from there. So that's here, Microsoft historical, my Microsoft. So I'm reading the data here from the common data model here. And you can see this is in my workspace. And then after that, I do all kinds of transformations here. So using mapping data flow in that case. And then I would say this is my Microsoft stock, my history of stocks here. So basically, let me go back for a few seconds here. So let me go here. So I copied the Microsoft stock data here. Microsoft stock data, I copied the old history. Before that, in my common data model, I had only 1 year of history. Now I go back to 1986. Same for Oracle. Now we can I go here. I will read the stock code that I have into my workspace, common data model, and the history that I have into my that I access directly, that I copied into my data lake from the web, from the copy activity I had before. Same thing for Microsoft. At the end of the day, what I want to get is I have the sync here, and I cannot do the data preview for now, but I want to get, I will show you the report I'm getting after. So because I need to start my cluster here because the time I was presenting is simply shut down. So I put the data into a table. So and the output stream is that, and this is I'm using stock quotes here. This is where I put that data. So now if I go to my notebook, I can do the same using not the data flow. I say notebook, which is open here. Yeah, I would have been able to do the same using Spark, right? Basically, I can read my data. Usually, I would use Key Vault for that. Read 1 year of data, union everything together, and at the end of the day, I get my data here. 1986, as you can see here. And so I can have a lot of data from here. So this is basically how we load the data using the common data model. I get a bit of the data in my data lake, in my common data folder. And then after that, I have two choices. Or I can bring it into my data lake and optimize it for data lakehouse, or I can put it back into the common data model folder and use it like a model. And I can link it to an existing entity that we can find in dynamic CRM, like accounts or stuff like this. So when I want to consume it from my my Dataverse for my applications, I can say, okay, this is this type of data. This is an account data. I'm going to use it there. This is my stock data. My finance data would say this is how I'm going to use it. So now this is my demo for Altigrade. Time flies. So let me go back to my presentation here. Right. And okay, so let me go back to the presentation. And this is where I was, basically the demo. So now, how are we querying this data? Okay. 2 seconds here. Escape. We go back to my presentation here, and I want to slideshow presenting teams. Perfect. Right. Okay, and let's go back to further away. Yeah, resume from slide 40. That's perfect. We love Teams. And hide presenter view. Okay, so now querying the data warehouse, the modern data warehouse. How it's a data lake structures. It can be a database. How am I going to do it? I can use Databricks or Synapse notebook here. I can use SQL Server is data if the data is copied over to it, or if I can access it directly from SQL Server using Polybase, I could do it. Use XML endpoint that come with Power BI Premium here. This is how XML endpoint. This is how we access the data since we have cubes. I'm going to talk about that in 2005. And we can use Synapse Serverless SQL Pool or Power BI. So the first thing is to use Databricks or Synapse Notebook with Delta table. So this is what we use, what the data scientists will use to find the feature that they need for their experiments, right? What do they want to predict, or what's the data content here? And this to design proof of concept report, but it's not meant for casual report consumer. I'm going to show you after what I mean about that. XML endpoint, as I mentioned, they exist since 2005 here. So this is basically I can access it using SQL Server Management Studio. I can access it using using a bunch of other tools like Tableau, Power BI, Excel. This is the best way to use it. So basically, we're using the cube capability of Power BI, so the model of Power BI, to access the data. So it means that the data has to be accessible from the Power BI model. And here is the demo. Let's stop presenting again. Stop presenting, and let's go here. So if I can do the data scientist, sometimes I will do a chart here, right? So I can do a chart, Yeah, so I don't see a lot of things so far. I don't have the right data for it, so I just see a date here. So I can do a chart. I can modify that type of chart. I can export it to CSV, JSON, or XML here. So I can do a lot here. So view option, I can say, you know what, let's do a line chart. If it's accessible. No, it's only the column chart that is accessible for now. Okay, for this type of data. Oh, yeah, okay, I need to choose. Yeah, line chart, high, low, perfect. Okay. We have delay here. Okay, apply. Yeah, it's going to apply. So as you can see, I can see some results here, but this is not what I want to, how I cannot ask my operational users to use this type of reporting. It's mostly for data science usage here. Also, I can use some libraries like pandas profiling here to do to profile the data. I can use a lot of things. I can do a lot of things with Databricks and Spark here. The best way to do it is to create a data set, a model, basically, and then from there I can create a report. So we have delay here. I can create a report, and that report will be Power BI here, and I say create a report. So, and from there now I have the model here that will appear. And this is based on, yeah, this is my new report. I can rename it, but this is based basically on the model, the fields here that I created from my common data model. So I can bring a few things here. Close, these are all the keys I have, but I will show you to save time. I will show you what I did. So this is the Power BI report here that I took time to a few minutes to create here. So I can see that volume by year by company here, Microsoft, Oracle, and then the volume over the years from 1986 to end of 2020. This is the data I had. And I can also switch company here. I can say, you know what, let me Microsoft. No, I prefer to use or Oracle. I can do it. So I can do a lot here. So this is how we can report basically. Now the XML endpoint, I go to Power BI. I go here, I will go to my workspace. And from my workspace here, let me go to my workspace, Power BI, and I want to access my settings here from, I don't want to create a pipeline, I'm sorry. So let me go to workspace here. Here, perfect, thank you. Workspace setting, finally. So I go to the premium capacity here, and from the premium capacity, I can have my workspace connection. If I click on that here, I can start Excel and consume that data here. So if I go to Excel, here, start Excel, and we'll connect to this blank workbook. So the way we connect to it with Excel so far, thank you, is data and get data from database analysis services. I paste the workspace name here, not Windows authentication, the following authentication. Now, from there, I'm going to be able to connect using my email address here, and I should be able to access the data. Yeah, this is my model here, and let's finish. Perfect. All right, now you see, this is the same thing I had, Microsoft stock, Oracle stock here. You have the company name here, so it depends what type of model I want to do. And yeah, so I can do the same here. So this is how I can use the Power BI XML endpoints to connect to my workspace here. So I have the company name here. So let me remove this and put into the filters instead, and then I can choose what company I want. So I can do anything with the exclamation point that I was able to do from a cube. I can also, from the exclamation point, refresh a specific table in my model. So it's very powerful. All right, now let's go back to the presentation here. And slideshow, presenting things. Let's go back here. We're almost done. So let's resume from here and remove and present view. Perfect. Okay. So go navigate forward, please. I think we have a small delay here. Okay. What are the challenges on-prem versus cloud? Basically, the security, right? Security, people will always say security is a major concern, but it's more secure in the cloud than it is on-prem most of the time, unless you're not connected to any network on-prem, which is impossible. It's much more secure here. Reality versus uptime, right? So cloud vendors will spend millions to ensure reliability and uptime. 100% of the time is impossible, both on-prem and the clouds, but the guarantee 99.9x uptime of their services, and the more lines you have here, the more expensive it's going to cost. And what I like with platform as a service is that I don't need to install Visual Studio or anything. A web browser is sufficient here. Now, to sum up, cloud data integration allows us to ingest more data sources and more data sources type and volume that we had before. All the tools that MarBI has, Power BI, Data Factory, Synapse, Databricks, are the main tool used in modern data warehouse, and Stream Analytics is part of that too. And you will encounter more and more Cosmos DB for NoSQL data here. The modern data lakehouse is where the industry is leading, slowly but surely for sure. And in my day-to-day work, we're migrating data from on-prem to the cloud, and we rarely do a good old enterprise data warehouse. We're going to do a lake house here. Do not lift and shift all of your stack to the cloud as they are on-prem. So it means that don't create a VM, infrastructure as a service. Use platform as a service as much as possible. So don't use your database that you have on-prem, restore them into the cloud. You don't gain anything except that you don't need to manage the servers on-prem. So it's much easier to, it's easier to do, but you're going to pay at the end because it will not be as flexible and you don't embrace the cloud much with that. All right, so special thanks to Microsoft for supporting Data Platform Geeks and SQL Server Geeks. And thank you very much. And post yourself in hashtags here, and you will win prizes at the end. Right? Thank you very much.